Hello students, welcome back to all of you. In this module we are going to discuss about 2 mark questions which were given in real numbers chapter, and if I am not wrong, you can identify 2 marks problems are just similar to 1 marks problems. Sometimes 2 marks problems are pretty much easier than 1 mark problems also, right? So let's see what kind of problems were given. And here in this, the very first problem is the total number of factors of prime factor of prime number is. See here, of course, this is 1 mark problem. The total number of factors of prime number is. Factors of a prime number. You take any prime number. For example, I am taking a least prime number. Of course, it's an even prime number also. What are the factors of 2? 1 is a factor and 2 is a factor. That is why the number 2 is said to be a prime number. So a prime number has maximum of 2 factors. Maximum of 2 factors means if I would say that it has exactly 2 factors. Exactly 2 factors. Maximum of 2 factors means again it is going to contradict the statement, because maximum of 2 factors means it can have 1 factor also. No, it's not like that. A prime number has exactly 2 factors. What are those 2 factors? 1 and itself are the factors of a prime number. So the total number of factors of a prime number is 2, right? Moving on to the next problem. Here the next problem is the LCM of smallest 2-digit composite number and the smallest composite number is. The LCM of smallest 2-digit composite number. What is the smallest 2-digit composite number? What are 2-digit numbers starting from? 2-digit number starts from 10, next 11, next 12, and so on up to 99, of course. So what is the smallest number out of all these? 10 is the smallest number. Is that 10 a composite number? Obviously composite number, because 10 can be expressed as 2 times 5. So the smallest composite number is going to be smallest, okay, smallest composite number, smallest composite 2-digit number, smallest composite 2-digit number is going to be 10, okay, number is equal to 10. And what is the next one? And the smallest composite number. What is the smallest composite number? 2 is the smallest composite number. And smallest composite number is going to be, smallest composite number, right? Smallest prime number is 2, but smallest composite number is 4. So smallest composite number is equal to 4. Now you are going to find what is the LCM of these two numbers. Okay, fine. I am taking 4 and 10. I try to find the what is the LCM. That is 2 times 2 equal to 4. 2 times 5 is equal to 10. Again, 2 and 5 cannot be divisible by any other number, so that the LCM is going to be LCM is equal to 2 into 2 into 5. 2 times 2 equal to 4. 4 times 5 is equal to 20. So 20 is the smallest LCM of smallest composite 2-digit number as well as the smallest composite number, right? Next, the next problem is going to be if two positive numbers a and b are written as, where a is equal to x cube into y square and b is going to be, what is the value of b here? B is equal to xy cube, where x and y are prime numbers. Then find what is the LCM and HCF of a and b. I think we discussed similar kind of problem. So taking x cube into y square, next number is xy cube, right? So going to find LCM by L method. Here x cube and x, so that x is the maximum one. So x squares are x cube and y square is already there. X ones are x, remaining y cube. So there is no common x in both because x is there only in the first term. Next, y square and y cube. So y square is maximum. I am taking y square. Y square ones are y square, remaining x square. Y square y's are x y cube. So x square and y cannot be divisible by any other number except 1. So that what is the HCF of these two numbers a comma b? HCF of these two numbers is going to be x into y square, means xy square is the HCF. And what is the LCM of a comma b? LCM of A comma B is going to be HCF into the product of other factors. Other factors are x square into y. Okay, LCM is equal to HCF of other two factors. And please do remember one more thing I would like to tell you here. In order to find HCF of the numbers, HCF should always be a factor of LCM of the numbers. HCF is always be a factor of LCM of numbers. So HCF is going to be xy square into x square y. So x into x is equal to x square into x is equal to x cube into y square into y is going to be y cube. So x cube into y cube, of course you can even write this as xy whole cube also. So xy whole cube is the LCM of those two numbers and HCF is going to be xy square, right? See, they are about 1 mark problems. Now we are going to discuss 2 markers. So 2 marks problems, I already told you, sometimes 2 marks problems also pretty much easier than 1 mark problems. Sometimes you get direct problems also. But please do remember the marking scheme. According to the marking scheme, you will have to provide every single step which is required. Okay, let's move on to the first problem. HCF of 144 and 180 is expressed in the form of 13m minus 3. Then find the value of m. See, there are so many ways to find HCF of the numbers, and there is one more very interesting and easy method, that is short division method. I am going to find what is the HCF of these two numbers by short division method. What is that method? Take 180 means the bigger number, divide the bigger number by the smaller number, that is 144. I hope you know this method. I would like to explain one more time. 144, how much are a number which is less than or equal to 180? Of course, once it carries, it goes 1 times 144 and then subtract. 10 minus 4 is equal to 6 and it is 7. 7 minus 4 is equal to 3. So 36. Now take that 36 as the divisor. Take that 36 as the divisor, and whatever the divisor in the first case or previous case, it would be the dividend for the next case. So take 144. Hope you understand. And again perform the division. So before you perform the division, see it is 36. 30 and 6. Just I am trying to identify the closure number. 34s are 120. 35s 150. So if you take 36 5s, I think you are crossing the number. So I will try with 4. Okay, so I am trying with 4. So 4 6 are 24, 4 2, 4 3s are 12, plus 2 equal to 14. You are getting the remainder 0. Since you are getting the remainder 0, what is the divisor in the last case? See, this problem ends with only 2 steps, but sometimes in order to find HCF of the given two numbers may end in 5 steps or 6 steps or 7 steps, like 5 divisions or 6 divisions. But here this problem ends in only 2 divisions. Whatever the divisor in the last division, so that divisor can be declared as HCF of the given numbers. Hope you understand. So therefore HCF of what are those two numbers? 144 and 180 is going to be 36. Now according to the problem, HCF is expressed in the form of 13m minus 3, means this value is going to be HCF. So that is 13m minus 3 is equal to 36. Will you be able to solve for m? Yes, of course you can transpose 3 that side. So 13m is equal to 36 and minus 3 will become plus 3. 13m is equal to 36 plus 3 equal to 39. 13, how much are 39? 13 3s are 39. See how easy to get the answer, right? Moving on to the next problem. Here the next problem is find the value of minus 1 power n plus minus 1 power 2n plus minus 1 power 2n plus 1 plus minus 1 power 4n plus 2. Okay, I am going to write this here. For example, I am going to take this entire number is some p. P is equal to minus 1 whole to the power of n plus minus 1 whole to the power of 2n plus minus 1 whole to the power of 2n plus 1 plus minus 1 whole to the power of 4n plus 2. See, if you use your brain, we can answer this problem easily. You know how? Minus 1 to the power of odd number. Minus 1 to the power of any odd number, because minus power any odd number will be minus. So it means minus 1. Minus 1 to the power of even number is always plus 1. Provided these two conditions, I am going to rewrite the given problem as minus 1 to the power of 2n. What is minus 1 to the power of 2n? 2n is the general form of even number, isn't it? So, minus 1 to the power of even will always be positive 1, right? Minus 1 to the power of 2n plus 1. 2n plus 1 is again an odd number. So, minus 1 to the power of odd number is going to be minus 1. So, minus 1 into plus 1 equal to minus 1. Again, minus 1 to the power of 4n plus 2. 4n is an even number, 2 is also even number. Even plus even equal to even. So, minus 1 to the power of even is always even. So, minus 1 power even is always equal to positive 1. Got it? So, here itself minus 1 and plus 1 cancel. But we cannot say about this. So, I am going to write this minus 1 whole to the power of n only. So, finally, my p without substituting any value of n will become p is equal to minus 1 whole to the power of n plus 1. Now, when n is equal to 1, n is equal to 1 means n is equal to, let us go by even and odd, right? So, when n is equal to, I am going with odd. When n is equal to odd, so p is equal to what? Minus 1 whole power odd number. Minus 1 whole power odd number is minus 1 plus 1. Minus 1 plus 1 is equal to 0. So, for n is odd number, it is 0. And what is when n is even number? When n is even, then p is going to be minus 1 whole power even number is always positive 1. So, 1 plus 1 is going to be 2. So, when n is odd number, it is going to be 0. When n is even number, it is going to be 2. So, this way we can answer the problem easily. Moving on to the next problem, HCF of 336, 54 is 6. Then what is the LCM of those two numbers? Have you any idea about LCM and HCF of two numbers? Yes, there is a standardized result in order to find LCM and HCF of two numbers. For example, if your two numbers are A and B, then what is the relationship between LCM and HCF of these two numbers? That is LCM of A comma B into HCF of A comma B is going to be product of those two numbers A and B, that is A multiplied by B. So, LCM of two numbers multiplied by HCF of those two numbers is equal to product of two numbers. As simple as that. You don't have to find what is the LCM of 336 and 554 by your L method or prime factorization method. Just by using this logic, you can easily find what is the LCM of the numbers or HCF of the numbers when the numbers are given. Okay. See here, the problem is LCM of A comma B. What is the LCM of A comma B? That is 6. And what is HCF of A comma B? Sorry, I don't know what is the LCM of A comma B, right? So that I don't know what is the LCM, because I am going to find LCM here. So that I would write LCM of what are the numbers? 336, 54 into HCF of those two numbers is going to be 6 is equal to product of two numbers. What are those two numbers? 336 multiplied by 54, right? See, are you really finding LCM by factorization method? No, not at all. So that transposing this 6 towards right hand side, therefore LCM of 336 comma 54 is equal to 336 into 54 divided by 6. Will you be able to simplify this? Yes. 6 ones are 6. 6 9s are 54. So finally the result remains 336 times 9. So 9 6 are 54, 4, 5, 9 3s are 27 plus 5 is equal to 32, 2, 3, 9 3s are 27. plus 3 is equal to 30. So 3024 is the HCF of the given two numbers. Sorry, LCM of the given two numbers. See how much easier this is to find LCM of the given two numbers with the given information. So moving on to the next problem here. Two tankers contain 850 liters and 680 liters of petrol respectively. Find the maximum capacity of a container which can measure the petrol of either tankers in exact number of times. So this is sometimes kind of a confusing thing, that what has to be done exactly. What has to be done exactly? I have taken two numbers. Those two numbers are 850 and 680. Okay, these two are two numbers. According to the problem, I will tell you one easiest context, that is, according to this problem, what is the number which exactly divides both 850 and 680? What is the number? See, 2 is the number which divides both of them, but 2 is not only the number dividing both of them. Maybe 3 also, maybe 4 also, maybe 5 also, maybe 6 also. So in that, you need to find what is the maximum number, what is the greatest number which divides both the two numbers. The greatest number which divides both the two numbers. What do you mean by the greatest number which divides both the two numbers? That is the highest common factor of both the two numbers. So it is understood that you are asked to find what is the HCF of these two numbers. So according to the given problem, we have to find HCF of, what are those two numbers? 850 and 680. You understand? So now you have many methods to find HCF. I'll go by short division method. Okay, so taking 850, dividing 850 by 680. Okay, 600 800 only one time it will go, so 680. Then 0 minus 0 is 0. What is 15 minus 8? 70. Sorry, 7. So this is 7. 7 minus 6 is equal to, this is 8, right? Already taken 1. So 7 minus 6 is equal to 1. 170. So again 170 will be the divisor, and this divisor will be the dividend. So 680. Now how many number of times? Let us go. Let us check our calculations all the time. 680 ones are 680. 0 minus 0 equal to 0. 15 minus 8 equal to 7. Okay. And then here it is 7 minus 6 is equal to 1. 170, 680. How many number of times? Suppose if you go by 6 times, for example. 600, this is 170. 100 and 70. If you go by 6, 600s are 600, okay. But 6 sevens are how much? 42. Means 400 again. So 600 plus 400 is equal to 1000. So that it is not possible by 6. Then let us think. If you go by, for example, 4. 17, how much are 68? 17 4s are 68. So 17 4s are 680. 680, remainder is going to be 0. So 170 is the HCF of those two numbers. So HCF of 850 and 680 is going to be 170. So according to the problem, the maximum capacity of the container. So therefore, maximum capacity of the container required, is equal to 170 liters container. So with the help of this 170 liters container, we can easily measure both of them exactly. Understand? So in this kind of cases, you need to find HCF of the given two numbers. So moving on to the next problem. Here the next problem is explain why this number is a composite number. So here, what kind of numbers are composite numbers? What kind of numbers are composite numbers? So according to the definition of composite number, a number which has at least 3 factors is said to be a composite number. A number which has at least 3 factors means what? 3 or more than 3 factors. then that number is considered as composite number. Because if a number has exactly two factors, then it is said to be a prime number. So that a number has 3 or more than 3 factors can be considered as a composite number. And see, simply if you can find out at least one factor of that other than 1, then that number is a composite number. See this number, what is the last digit of the number? Last digit is equal to 5. Since last digit is equal to 5, then will you be able to write that number, or will you think that this number is exactly divisible by 5? Absolutely. So you can write this entire number as 5 into something. Okay, whatever that something is. Now this number has minimum of factors. 1 is the factor, 5 is the factor, and this entire number is the factor. Again, whatever the given number, that number is also the factor. See, easily without performing any calculations, we can say that this number is a composite number because it has minimum of 4 factors, not 3 factors even. Minimum of 4 factors. So just by looking at the last digit, that is the unit digit. Suppose if the unit digit is an even number, then also that number is a composite number. If the unit digit ends with 0 or 5, then also that number can be considered as a composite number because we can express in this way. Right? Next. Moving on to the next problem. So write one rational and one irrational number lying between 0.25. So 0.25 is one number, 0.32 is another number. Now we are going to write one rational and one irrational. Before going to write rational or irrational, what kind of a number is a rational number and what kind of a number is irrational number? See, every rational number can be expressed in the form of P by Q, where Q is not supposed to be 0. P comma Q are integers. P comma Q are integers. Integers are nothing but should be in the standard form all the time. Simplest form. See, every rational number of this form can be expressed in decimal expansion. And what kind of decimal expansion? Suppose if you can write that Q as 2 power something into 5 to the power of something, where those somethings are m comma n are whole numbers. If you can express the denominator, then this kind of numbers are said to be terminating decimal. What do you call that? Terminating. Terminating decimal is nothing but the decimal will never repeat. That is what called terminating decimal. Suppose if Q cannot be expressed in the form of 2 power something into 5 to the power of something, then this kind of decimal expansions are non-terminating but repeating decimals. Non-terminating but repeating decimals. So these kind of numbers are rational numbers. So every rational number can be expressed in the form of P by Q, means in the form of a decimal expansion. Those decimal expansions are either terminating decimal or non-terminating but repeating decimal. But there is one more type of decimal expansion, that is neither a terminating decimal nor a repeating decimal. So what is that neither a terminating nor repeating decimal? The decimals will not repeat in a proper order. You understand? See, suppose if I take one number, here terminating decimal is nothing but if you have terminating decimal some 0.75, that's a terminating decimal. And what is this non-terminating decimal? Non-terminating decimal but repeating decimal means I can say 0.2 53253 and so on. See, there is a particular number of digits are repeating, but neither terminating nor repeating decimals are nothing but I have a number 0.13, 14, 15, 16 and so on. This is one neither terminating nor repeating decimal. This kind of decimal expansions are said to be irrational numbers. So irrational numbers are nothing but neither terminating nor repeating decimal. Hope you understand now. See, now it is pretty much easier to write one rational and one irrational number. So first rational number between both of them. Rational number between 0.25 and 0.32. So it should be more than 0.25 and less than 0.32. This is 0.2 and this is 0.3, right? What is the number which is more than this? More than 25. Can I write it as 0.26? Because it is more than 0.25. Can we say that it is less than 0.3? Yes, absolutely. So 0.26 is one example for a rational number between these two numbers. Now I am going to write one irrational number between them. So irrational number is nothing but it's a neither terminating nor repeating. 0.25 is one number and 0.32 is another number. I just want to know what is the irrational numbers between them. So irrational number is 0.25 is this and 0.32. Now I will take this 0.26, 27, 28 and so on. So this number is more than this and less than this. So this number is an irrational number between both of them. Like that we can write infinitely many number of rational numbers as well as irrational numbers between given two numbers. You understand? Next. So moving on to the next problem here. What is the HCF of the smallest prime number and the smallest composite number? So what is the smallest prime number? Smallest prime number. So smallest prime number is going to be 2. That is the smallest prime number. And what is the smallest composite number? Smallest composite number in the sense it's a single digit composite number and it should be smallest. So smallest composite number, you know that it is 4. Now you are going to find what is the HCF. So HCF of 2 comma 4. What is the HCF of 2 comma 4? Of course highest common factor of 2 comma 4 is 2. So this way you can answer this problem. Next, find HCF and LCM of 404 and 96 and verify whether HCF into LCM is equal to product of the numbers or not. You will have to list out everything here. Finding out LCM and HCF. I am going with the L method. So it would be easier for me to list out what is HCF and what is LCM directly. Okay. Right. I am going with the common factors. See, it is divisible by 4. This one also divisible by 4. So 4 101s. And here it is 4, 2s are 8, 4 4s are 16. And 101 is a prime number, isn't it? 24 is a composite number. So 101 and 24 cannot be cancelled by any other numbers. So what is the HCF of two numbers? HCF is equal to 4. And what is LCM? LCM is going to be HCF into other two numbers. That is 4 into 101 into 24. So then it is going to be 4 into 101 into 24 equal to 101 into 24. 4s are 96. Okay. If you multiply them, then it is going to be maybe multiplication with 1 is easier. 96 ones are 96, 0, 0 and 1. So 96. This is 9696. Okay. 9696 is the LCM. And what is the next one? The problem that given it is you found what is the HCF of the numbers and you found what is the LCM of the numbers, and later you will have to verify whether LCM into HCF is equal to product of two numbers or not. Now I am going to write LCM into HCF. LCM into HCF equal to 9696 into 4. So 4 6 are 24, 4 2, 4 9s are 36 plus 2 is equal to 38, 8 3, and then 4 6 are 24, 24 plus 3 is equal to 27, 7 2, 4 9s are 36 plus 2 is equal to 38. This is what is the LCM into HCF. Now what is product of two numbers? That is A into B is equal to 404 multiplied by 96. So 9 6 are 54. So it is also going to be 378.84. So therefore LCM into HCF is equal to product of two numbers. It's pretty much easier because this is like simple multiplication. Okay. So this is what is the last problem which was given in two marker questions. short answer questions. Okay. See, I think you when you answer this problem, you feel easier, right? Because 2 markers, 1 markers, even when we discuss 3 markers and 5 markers also, they're all pretty much easier problems. But the only thing is, you will have to follow accordingly, okay, and utilize your time so that you will definitely score more than 80%. Hope you understand. Enjoy the class. Thank you.